Okay, guys, time to go through some chemistry MCQ multiple choice questions. This first one says, what is the best oxidizing agent? So, what we've got to ask ourselves is, what is an oxidizing agent? That's the first thing we need to understand before we can try and do this question. So, oxidizing agents make something else become oxidized. They make something else lose an electron. And that means the oxidizing agent itself gets reduced. So, here, this little smiley face is the oxidizing agent, and it's going to make something else lose an electron by stealing that electron off of it. So, for instance, the oxidizing agent is itself reduced. Reduction is gain of electrons. The oxidizing agent gains an electron but causes the other thing to lose one. So, let's look at these four things A, B, C, and D. We have fluorine, fluoride, iodine, iodide. Which of these is going to want to take an electron? Well, a fluoride ion has no room to take an electron. And the same goes for an iodide ion. If you look at them, they've got a full outer shell. So how can they take an extra electron? So these cannot be oxidizing agents. They can't make anything lose an electron because they've already got them. So our answer has to be either fluorine or iodine. And if we draw out fluorine, fluorine could, of course, take on an electron. It's got 7 electrons in its outer shell, and it could take one on. But so could iodine. Iodine can also be an oxidizing agent. As you can see here, iodine is a slightly bigger atom than fluorine. Um, what does that tell us if it's slightly bigger? Well, that tells us that the electron it's going to gain is further away from the nucleus. So the fluorine is going to be the better oxidizing agent because that outer electron is closer to its nucleus and so more able to feel that positive charge. So if you answered C, it is an oxidizing agent, but the correct answer is A. Fluorine is the better oxidizing agent. It's got greater attraction to its, as the outer electron that it's trying to gain is closer to its nuclear charge. So fluorine is one of the strongest oxidizing agents in the whole of the periodic table. Okay, let's look at another question. So we know the answer here is A. So let's zing to the next question. Which of these species is the best reducing agent? Hey, we got to ask ourselves, what does a reducing agent mean? What does it mean if you're a reducing agent? Well, a reducing agent wants to cause something else to gain electrons. Okay, so it's trying to make something else gain an electron. So the reducing agent itself must lose an electron. The reducing agent is oxidized. So what we're really asking ourselves here is who's most likely to lose an electron and give it to someone else, causing them to be reduced. So let's look through the structures again. We've got chlorine. Would chlorine want to lose an electron? Well, it's got 7 in the outer shell. It's trying to gain an electron. Chlorine and iodine as well are not going to be viable reducing agents. So really we need to look at the chloride ion and the iodide ion over here. So this is a chloride ion and an iodide ion, and we can see that iodide is bigger and has a full outer shell. It's more easy to lose that electron it gained and go back to being iodine. So iodide is the best reducing agent out of the halogens, and that's something you have to know for your AQA chemistry specification. So the answer here is D. The iodide ion is larger and more likely to lose an electron. Okay, looking at this next question, we're dealing with an NO2 minus ion that can be reduced, which means gains an electron, to become NO. How many electrons does it need to gain when each NO2 minus ion is reduced? Well, let's have a look at this. NO2 minus goes to NO. So if we look at the oxidation state of oxygen, which is always -2, unless it's with a fluorine atom, we'll see that there's 2 oxygens here. So there's a total of -4 negative charge in this NO2 minus ion, which means that the nitrogen atom must have an oxidation state of +3 because +3 -4 equals minus overall. When it becomes NO, we can see that the oxygen will still be -2. The nitrogen must now be +2. So how many electrons has it gained if it's gone from +3, the nitrogen, to +2? It's gained 1 electron. And we can see that. So the answer was A. Okay, now we're going to get into the final question. Which of the following shows chlorine in its correct oxidation states in the compounds shown? So we really just need to work out what the oxidation state of chlorine is in each of these. We can see hydrogen's +1, chlorine must be -1. Over here, we know that oxygen is always -2, so we go 3 times -2 is -6. Potassium is a group 1 metal, so it's +1. That leaves +5 for our chlorine atom. Over here in hydrogen chlorate, hydrogen's +1. We know oxygen's -2, which means that the chlorine atom must be +1. Therefore, our three oxidation states are -1, +5, and +1. And the answer for that is C. Okay, guys, check out some other packs, work through them, do the questions. Let's get to the marks.